Formative exercise 8.1, questions 1. The mud deposited on the riverbed makes the river that runs through a village shallow. This makes the boats traveling in and out difficult. Boats that move along a jetty in a straight line with displacement s meter, t seconds after passing the jetty is given by s equal to t squared minus 4t. A. Copy and complete the table below. To find the displacement, we just need to substitute the time given in the table into the t in the displacement functions. Then the answer will be -3, -4, -3, 0, and 5. Questions B. Sketch the displacement time graph to show the positions of the boat. So based on the displacement function, this is a quadratic graph with a equal to 1, which is greater than 0. Therefore, the shape will be a small one. Here, the c is equal to 0. This means the graph will start at the origin. And using the information that we have in the table here, then we can sketch the graph. And this will be the displacement time graph of the s equal to t squared minus 4t. Question C. Find the times in seconds when the boat is at the jetty again. In these questions, the jetty is the fixed point O. So based on the graph, when t is equal to 0, s is equal to 0. This means the boat, it at the fixed point O when it started. And from 0 to 2 seconds, as the displacement is negative, then the boat is moving to the left-hand side of the jetty. And from t equal to 2 onwards, the boat turn and moving in the opposite direction, which is to the right. So when the boat is at jetty again, the displacement will be equal to 0. So when the time is equal to 4, the displacement is equal to 0. So the answer for C will be 4 seconds. So for question C, this is the same as the question is asking when the particle is passed through the fixed point O again. We are going to refer to S equal to 0. Questions number 2. Shazza cycles her 3-wheel bicycles in the straight line and the house backyard and has an initial displacement of 2 meters from a flower pot. Her displacement s meter t seconds after passing the flower pot is given by s equal to t cubed plus 2t plus c. A. Determine the value of c. In these questions, the flower pot is the fixed point O. And this information means at the start, which is t equal to 0, Shazza is 2 meters on the right hand side of the flower pot as the displacement is a positive one. So when we substitute the t equal to 0 into the displacement function here, s is equal to 2. So this number 2 will be the value of c. Questions B. Find the distance of Shazza from the flower pot when number 1 t is equal to 2. So here we just need to find the displacement, as displacement is the distance of the particles from the fixed points measured on a certain directions. So for B1, we're just going to substitute t equal to 2 into the displacement functions. So it will be 2 cubed plus 2 times 2 plus 2, which is equal to 14. So the distance from the flower pot to t equal to 2 will be 14. Questions number 2, t equal to 3. So here we're going to substitute t equal to 3 into the displacement functions. So it will be 3 cubed plus 2 times 3 plus 2, which is equal to 35. So the distance from the flower pot to t equal to 3 will be 35. Questions number 3. A particle moves along a straight line from a fixed point O. Its displacement s meter t second after passing through O is given by s equal to 3t squared plus 2t. Calculate the instantaneous displacement of the particles when t equal to 0 and t equal to 10. So here the instantaneous displacement means the displacement of a particle at a certain time. So to find the instantaneous displacement, we just need to substitute the times given into the displacement functions. So when t is equal to 0, then s will equal to 3 times 0 square plus 2 times 0, which is equal to 0. This means the particles is at the fixed point O when t is equal to 0. When t is equal to 10, then s is equal to 3 times 10 squared plus 2 times 10, which is equal to 320. This means at t equal to 10, the particles is at 320 meters on the right hand side of the fixed point O. Questions number 4. The diagram on the right shows a boy kicking a ball in a field. The ball moves in a straight line and passes through a fixed point marked P. At t seconds after passing point P, the velocity v meter per second of the ball is given by v equal to 70 minus 5. Find the instantaneous velocity in meter per second of the ball when t equal to 2 and t equal to 4. So here the instantaneous velocity means the velocity of an object at a certain time. To find the instantaneous velocity, we just need to substitute the times given into the velocity functions. So when t is equal to 2, then v is equal to 7 times 2 minus 5, which is equal to 9. And when t is equal to 4, v is equal to 7 times 4 minus 5, which is equal to 23. Question number 5. A particle moves along a straight line and passes through a fixed point O. Its acceleration a at t seconds after passing through O is given by a equal to 4 minus 2t. A finds the initial accelerations of the particles. For initial accelerations, it happens at t equal to 0. So to find the initial acceleration, we just need to substitute t equal to 0 into the a. So it will be 4 minus 2 times 0. So the answer is equal to 4. Questions B. Determine the range of time in seconds when the velocity of the particle is decreasing. So this means the acceleration is negative. Then the a will less than 0. As a is less than 0 when the velocity of the particle is decreasing, then 4 minus 2t less than 0. Then negative 2t is less than negative 4. Then t is greater than negative 4 divided by negative 2. So here the inequality signs will be reversed as we divide it with a negative number. Then t is greater than 2. Questions number 6. A particle moves along a straight line and passes through a fixed point O. Its displacement s meter at t seconds after passing through point O is given by s equal to 2t squared plus t. Calculate a, the displacement in meter of the particles when t is equal to 3. So here we just need to substitute t equal to 3 into the displacement functions. Then s is equal to 2 times 3 squared plus 3. Then the answer will be 21. Questions B. Calculate the total distance in meter traveled by the particle in the first 5 seconds. So here we can determine the total distance by either using the number line or the displacement function graph. So for this question, I'm going to use the number line. But before that, we're going to determine the displacement of the particles for each second starting from 0 until 5 seconds. Then substitute the times into the displacement functions. Then the answer will be 0, 3, 10, 21, 36, and 55. Then next, we can transfer the displacement onto the number lines. So the particles move in one direction, which is to the right of the fixed point O, starting from the times t equal to 0 until t equal to 5. Therefore, the total distance will be 55. Questions number 7. A particle moves along a straight line. At time t seconds after it starts moving, its displacement s meter from the fixed point O is given by s equal to t minus 2 square plus 5. A. Copy and complete the table below. To complete the table, we just need to substitute the times given into the displacement functions. So the answer will be 9, 6, 5, 6, 9, 14, and 21. Questions B. Sketch the displacement time graph for the time in between 0 to 6. If we expand the displacement functions given, we're going to get t squared minus 4t plus 4 plus 5. Then this is equal to t squared minus 40 plus 9. So this is a quadratic function with a equal to 1, which is greater than 0, then we're going to get the shape of a smile graph. And the y-intercept, which is c, is equal to 9. And with all the data from the table in A, now we can sketch the displacement time graph. So this will be the displacement time graph look like. Question C. Calculate the total distance in meter traveled by the particles in the first 6 seconds. So from the y-intercept here, which is t equal to 0, s equal to 9, the particles is at 9 meters to the right of the fixed point O at t equal to 0. So from t equal to 0 until the minimum point here, which is t equal to 2, the particle moves to the left until s is equal to 5. So the distance here from t equal to 0 to t equal to 2 will be 9 minus 5, which is 4. Start from t equal to 2 until t equal to 6. The particle turns and moves to the right until s is equal to 21. So the distance traveled from t equal to 2 until t equal to 6 will be 21 minus 5, which is equal to 16. Then the total distance will be 4 plus 16, which is equal to 20.